Hello, everybody. This has been a fantastic conference so far, and I'm glad to see such a big turnout for this presentation that I'm about to give. Yeah, as I said, I work at Red Hat, where I develop code for Red Hat storage. But I'm also a teacher at the University of Massachusetts at Lowell, which is a school of about 17,000 people, 25 miles northwest of Boston. And I've taught system administration there, and now I'm teaching intrusion detection, which has been a great area to become familiar with. So I'm going to talk about penetration testing in the cloud. And when I say the cloud, I just want to address one point. You could argue that it's a marketing term, but another point of view is that it is in fact a technical term. A technical term with these attributes: on-demand self-service, remote access, tenants that happen to be metered, and resources which are pooled and can grow and shrink. So we'll go with that definition for this talk when I talk about the cloud. These clouds come in different flavors, and I'll go over the different cases. So the public cloud obviously would be Azure or Amazon or Google or Rackspace. And there's the private cloud as owner. That is, you manage OpenStack. What are the implications there for penetration testing? And private cloud as tenant. So what can you do to do penetration testing when you are just in that instance? The purpose of penetration testing clearly is to do war games, so mimic real attacks. And your goal is to rehearse security processes and to stress your infrastructure. And there was a really good talk yesterday by Thomas Limoncelli, who spoke about reliability, and he made some good points which I think actually are analogous to the security world, such as you should avoid blame because that creates a bad culture. I think you shouldn't blame a security engineer, system administrator, if an attack, a zero-day attack, comes out of nowhere. You should have postmortems to review your security infrastructure. And maybe most importantly, you should expect problems, because who in the world could have known that a shell-shocked problem would appear just out of nowhere the way it did? So yes, I think the analogy of a certain level of security problems is analogous to, say, disks breaking in your data center. I think it's similar. There's another reason you may want to do penetration testing, and that's simple unit testing of IDS or firewall rules. The Linux tools in this domain, such as Mod Security, a WAF, Web Application Firewall, or Snort, a network intrusion detection system that's signature-based, OSEC, which is a host intrusion detection system, and a log aggregator, rootkit detector, and file integrity checker, and of course IP tables. They're all rule-based, and sometimes these rules get really complicated or chained together, and you'd want to unit test them. Same way you'd unit test a piece of code. So this is another reason to do penetration testing. Let's see, so you can do penetration testing in a safe hacker environment which is off the grid, and if you're very concerned, but in fact production system is probably better to really see the real implications of an attack. The tools available, the tools that you'd probably use in the Linux world, well, they come in two flavors. There's the catalog flavor, where there's just a lot of attacks sort of built in, and maybe you're not really sure what they do. They just go through a long, long list of attacks, and they'll report to you which vulnerabilities that they found. If you want to reproduce a particular vulnerability, like let's say Shell-Shocked or Poodle comes out, and it's not in Metasploit yet, you could turn to some of these low-level tools, such as Nmap, Network Mapper, for reconnaissance, or EtherCap for man-in-the-middle attacks, or HPing3 for packet crafting to build your own packet and put some crazy TCP flags settings. Curl is a very useful tool for this. TCP replay can replay packets, huge attacks that happened in the past, maybe on completely different machines, capture those and then replay them against your own machine, and that's really useful too. So I don't think it's of any surprise hackers are out there. I just left my Amazon instance up a few days and I got 76,000 attempts to get onto the root password. It's amazing. Representative attacks. So like I said, you have your zero-day attacks. I'm not going to talk about those because oftentimes the solution for those sorts of problems is to upgrade your software. So I want to talk more about canonical attacks that are baked into the IP protocol. Things that we have to live with because that's how the IP protocol is and how it's specified, and we're stuck with those issues ever since, such as spoofing. The IP protocol lets you change the source IP address of any packet you send out. Clearly, service providers block this, I know, but the problem is still there. It could happen on a LAN, for example. And theoretically, you could spoof a router, a trusted host, DNS server, whatever. A man-in-the-middle attack is another canonical, famous golden oldie. That is simply sniffing packets. If you compromise a router, you can see whatever packet passes through, or even modify it. Of course, this is why we have encryption and authentication, but not everybody uses those. So then there's distributed denial of service. This is essentially, as far as I know, basically an unsolved problem. It's a mitigated problem. Service providers may black hole when they see an attack, but maybe the attack is so spread out because it's so distributed that they can't recognize that it is an attack. And port scans, of course, are something that we all have to live with. What public clouds with respect to security? So first of all, I'd say that cloud providers such as Amazon and Azure and so on, they have rock solid security. They have as good as money can buy, and they lock down their data centers. They conform to all important specifications such as PCI. Their infrastructure is in a way resilient to denial of service attacks because it's so large and is spread out. Now, if you're an attacker and you're inside of an instance, the public cloud providers will do things similar to a service provider. For example, they won't let you spoof a source IP address. You cannot sniff another instance's traffic. You can't even see a wire. So it's impossible to do that. But and this is the big one, the public cloud providers will not protect your instance. They don't take responsibility for any ports you may have left open or software that you didn't upgrade. So that's your responsibility to deal with. So we still have to do penetration testing in the cloud. Now, the number one thing you have to recognize with penetration testing in the cloud is that you can't affect other tenants. So that's really the core issue. There's some other factors to consider, such as the cost. Obviously, you can't install a hardware security appliance. There's software security appliances. You don't have low-level access if in case you needed that. And IP addresses are ephemeral, so if you stop an instance and start it up again, you may find you have a different IP address, and therefore your firewall rule may have to change. It's something you have to keep in mind. So how do you go about doing penetration testing in the public cloud? Well, you ask them and get permission. and they'll give it to you, and they have policies. So each of the big cloud providers has their own policies, but basically they'll let you do it after you ask them. Some of them, and I won't say which, may be faster to respond to your request than others. Some are very, very responsive. As far as I know, none of them will let you do denial of service attacks. And on Amazon, you can't even do any penetration tests on their smallest instances. They're just careful in that regard. So, penetration testing in the public cloud is doable. There's various services that commercial vendors can give you. For example, they can do the penetration test for you if you pay them. They'll give you more bandwidth in case you have a denial of service attack, and that will swallow up the denial of service attack. And others will monitor your instances 24/7. But as pointed out by Mr. Limoncelli's talk, that last 9 of security, that extra level of protection, it gets more and more costly the more protection you want, and maybe you never reach 100%. So you can spend the extra money, but you have to weigh the value of that. So now let's talk about the private cloud and turn our attention to say something like OpenStack. And imagine you're the administrator of OpenStack and you've gone through all the pain of setting it, and it is quite painful, particularly with networking. So what are some of the things that you would want if you have your own OpenStack cloud and you want to do penetration testing? What's desirable? As always, you don't want to affect other instances. If you want to do penetration testing on a particular instance, you don't want to affect other instances in the same hypervisor. You probably want to observe instance traffic. It might be desirable so that when you observe it and process it via an IDS or a sniffer or what have you, that's not stealing hypervisor cycles from other instances. So you perhaps might want to fork that data off onto a separate machine. That's a desirable. And running an IDS against an instance might be a desirable. So this is OpenStack's software-defined network. And what's been really fantastic about this conference is I've gotten to learn so much more about it than I did before. I think for the purposes of this talk, what's interesting is that each instance has its own virtual bridge. Each instance has its own firewall, but the firewall does not live in the instance. The firewall lives in the bridge with the letters QBR up there. So if you set a firewall at the level of the cloud configuration, it's going to be done on that bridge. If you're about to look and you want to instrument a particular instance or group of instances, you may find that what you want to do is not available in OpenStack, and that's a problem. So you may find that you have to instrument these virtual bridges yourself, which is complex. And certainly you can look at the instance with a command like versh dump XML. It will give you the tap interface, and then you can do beer cuddle, bridge control show, and that will show you all the bridges, and you can see the tap interface is attached to that bridge. Okay, this is the one that I want to do TCP dump on. You can do TCP dump on a particular interface right there, or you can run snort on a particular interface. So if you really do need to get to that low level, that's one way to go about it. But in fact, what you would prefer to do is have some service provided to you, say IDS as a service from Neutron. And I think these are all basically emerging technologies. I haven't personally been successful in running that. I've had to concoct my own IDSs to particular instances, and I end up running multiple snorts on the same machine. And I have to give them all namespaces. So it can get pretty complicated. But hopefully the Neutron services will catch up with the needs of security people. Denial of service is an interesting topic in this space because what happens exactly on a denial of service attack? Well, I don't think there's a good answer there other than to say that clouds give quality of service to tenants. They'll rate limit the amount of traffic that can go through those interfaces. I'm not sure, but I think they use the traffic shaping software in Linux, or TC, traffic controller. So at least it's possible that you might be able to limit the problem to that interface. Okay, so let's talk about the point of view of the tenant, let's say in a private cloud. So if let's say I'm a tenant and I want to do penetration tests, and I go to my provider, my administrator, and I'm told, yes, you may do that, but you can't put anything on the network, nothing on the network. That's the rule. Well, you could attack from a container because a container, from the point of view of the instance, has its own IP address. In fact, it has its own subnet. In fact, it has its own NAT. It does packet tagging. It even has its own MTU. So if you want to, and I've done this, fragment packets or make really small packets or do fragmentations attacks, that's all possible. These are standard Linux interfaces and virtual bridges. A few funny things with containers, though. They do have a ceiling on resources, but they don't have a floor. So there's really no minimum guaranteed resources that a container can get. That may color some of the possibilities with, say, reproducing a denial of service attack. Also, it's worth pointing out that the external firewall is bypassed in this model. So if you go back to the OpenStack diagram, we have the firewall bridge, and we have the Docker container running inside of the instance. We're avoiding that firewall bridge completely. We're running inside the instance. In fact, this is a kind of nested virtualization, which I think is so super cool. Okay, so, all right, so let's explore this and see how far we can go with it. When you do penetration testing, a good distro, Linux distro to use is Kali, and it's Debian. And you want to run it on top of, say, Red Hat or CentOS. This is no problem with Docker. It works fine. So you're running Debian inside of Red Hat. And if you want to, say, import files into this, you can run a bash shell in there and import files into the Docker container. Say PCAP files that have records of previous attacks. Again, that works. So let's say you do a port scan, Christmas scan, null scan, ACK scan using Nmap. Your host instance can run snort. It would sniff the Docker interface, and as you can see, I got an alert. Spoofing, is quite possible. With HPing3, you can, like in this example, I set my source IP address to 22.22.22.22, and then I run TCP dump on the Docker interface, and lo and behold, there is that spoofed IP address. So spoofing can be reproduced. Man-in-the-middle attacks are a little bit more complex, but as mentioned earlier, you can run multiple Docker containers, and they're all on their own subnet, so they can talk to each other, and in fact, they're even sending ARP packets to each other. So with EtherCap, the way EtherCap works is it poisons the ARP tables of the victim. So I have two Docker containers, Docker 1 and Docker 2. Docker 2 is the attacker, Docker 1 is the victim. It runs EtherCap and tells Docker 1, hey, the ARP table for the ARP table for who you think you're going to send this packet to, it's really going to go to me. And so here I'm reproducing a code injection, PHP code injection attack, and because EtherCap lets you write little scripts to tell you how and where you want to change something inside of a packet. Again, that's a reproducible penetration test technique. And you can see my WAF captured that just fine. My web application firewall. Denial of service, I think it may be where the usage of this technique may reach its limit. You can do sort of unit testing of rules, but when it comes to resources, I'm not so sure. Because in fact, this is a process or process group, that you're running on the same machine, and everybody's sharing the same kernel. So it's kind of dubious. But for unit testing, I think you can be successful. So here I'm doing a few representative attacks. I'm doing a SYN attack where I just send the first packet to open a TCP connection in a three-way handshake, and I'm doing a random source address, and that works fine. I'm sending large UDP packets with the next one, and that works fine. Now I've actually run top, and I've seen the system slow down when I do this, but I'm not sure really what it means. And then Smurf attacks, which is another really old one. I was able to successfully do that. All right, so you can do pretty much anything you want to with Docker, so I would recommend it as a tool. You can even, if you like, run Metasploit. I ran the bash shell-shocked attack using curl right there. And for HTML, I use links, which is, as far as its HTML is concerned, it's fine. So in summary, penetration testing in the cloud is something you have to coordinate with your provider. I think OpenStack is very much a work in progress, but it's a promising work in progress. In particular, these Neutron services, I think, and virtual routers have a great deal of potential to address the needs of the security community. With respect to Docker, I think for unit testing, I think it's a good way to go. I'm pretty happy with how Docker worked, and I like the technology a lot. So thank you. That's all I had.
I wondered if you had done any penetration testing of Eucalyptus.
No, I've only looked into OpenStack.
So this might be a little unrelated, but what are your thoughts regarding the rules providers have for doing this kind of testing on other hosted networks? I mean, As somebody who, like, I'm a consumer right now of clouds, and I'm probably going to be getting into the provider business at my university. And so I run a relatively decently sized VMware infrastructure where I kind of have my classes contained that do information assurance and stuff like that. And we have been hesitating to put them out on the public cloud. So I know that you have clearly done a lot more research on this kind of thing than I have. I'm just wondering what your thoughts are with running what might be considered malevolent, even though it's not really malevolent against, you know, third-party targets.
So the question is running these tools inside the cloud, whether it's good or bad?
Yeah, I mean, do you feel like the current cloud providers frown upon that kind of thing?
You should ask them for permission. They say they'll let you do penetration tests. I don't see how you can do penetration tests without using those tools. They don't allow you to do denial of service attacks. So obviously when you do use the tools, you shouldn't use denial of service attacks. I take them at their word when they say when you do penetration tests that you're going to be doing some potentially some ugly things. How else could you do a penetration test? In fact, Metasploit probably uses those low-level tools. How else could it do these tests? So I think the answer to your question is actually the cloud providers are very accommodating. They understand the need for this. They're reasonable. I think Amazon is quite reasonable in this regard. With the exception of denial of service, you're able to accomplish what you want. Just get permission.
Have you looked into any other OpenStack components besides Neutron?
Besides Neutron?
Yeah. Have you looked into pen testing or?
Like, for example, CloudStack or something?
No, like Probe or any of the other OpenStack components.
No, I haven't. To tell you the truth, OpenStack is a bit befuddling to me. It's been really a tough slog to get used to it, and I think it's going to be able to do everything we want eventually, but you're on your own with OpenStack, so that's my experience.
With the amount of UDP services such as charge-in, NTP, and DNS that have been used in DDoS attacks of late, in particular NTP and DNS, do you really feel like you're doing an adequate pen test if your service provider won't let you test for those things? And how would you test? Would you have to just ensure that the local host is configured appropriately? So first, can you add a little more color to the question? So where's the limit? What type of attack, vulnerability? Amplification.
Oh, amplification, okay,
Yes.
Okay, yeah. Right, so amplification denial of service attack, gotcha. So that's like when a small packet becomes a very large one.
Correct.
Right. Well, you can unit test it. You can simulate it. I think actually my same response to denial of service problems in general would hold for what you're asking. Actually doing a denial of service attack in the cloud is something you're not allowed to do. Of course, if it's your own OpenStack system, perhaps you could speak with your sysadmin, or maybe you're the sysadmin, and you can do it. You just have to be careful that when you do your attack on a particular VLAN or set of instances, you're not affecting everybody. And that's where the QoS and rate limiting and traffic shaping of those particular instances comes into play. It's a tricky problem. I think denial of service is like one of the big open issues for computer science. Okay, I think that's it.